Hi, in this video, we will go through how to approach confidence interval under the Z procedure. A level C confidence interval, CI, for a parameter has two parts. 1. An interval calculated from the data, which has the form estimate plus or minus margin of error. 2. A confidence level of C, which gives the probability that the interval will capture the true parameter value in repeated samples. That is, the confidence level is the success rate for the method. When we use Z procedure, we need to check the condition again. We use the Z procedure if 1. The data is an SRS of size n, 2. From a normal population having 3. Unknown mean mu but known standard deviation sigma. The level C confidence interval for mu under Z procedure is x bar plus or minus Z star times sigma divided by the square root of n. That is, the interval from x bar minus Z star times sigma divided by the square root of n to x bar plus Z star times sigma divided by the square root of n. The level C confidence interval for mu under Z procedure is x bar plus or minus Z star times sigma divided by the square root of n. That is, the interval from x bar minus Z star times sigma divided by the square root of n to x bar plus Z star times sigma divided by the square root of n. During exam, you may find this question. A researcher conducted a study to estimate the average height of male adults in a certain city. The researcher took a random sample of 100 men from the city and measured their heights. The sample mean height was found to be 175 centimeters. It is known that the population height has a standard deviation of 15 centimeters. The researcher wants to construct a 95% confidence interval for the population mean height. What is the range of this confidence interval? Assume that the population follows a normal distribution. Step 0. Identify the question. We first verify whether the question satisfies the Z procedure. 1. The data is an SRS of size n equals 100. 2. The population follows a normal distribution. 3. We do not know mean mu but we know the population standard deviation sigma equals 15 centimeters. Then, we can calculate the 95% confidence interval under the Z procedure. Step 1. Copy the formula for confidence interval under Z procedure. You can find the Z interval formula in the formula sheet as x bar plus or minus Z star times sigma divided by the square root of n. Step 2. Identify numbers. You can identify the symbols in the Z interval formula. X bar is 175 centimeters, which is the sample mean height. Sigma is 15 centimeters, which is the population standard deviation. N is 100, the number of men sampled from the city. Z star is the critical value that can be found in Table C from the formula sheet, and a minimized version is provided here. Different C levels will have different critical values. The question requires a 95% confidence interval, which means that the confidence level is 95%. We check the critical value under the column 95%. We have the Z star to be 1.960. Step 3. Substitute numbers. We, then, substitute everything into the formula. We have 175 plus or minus 1.96 times 15 divided by the square root of 100, which equals the interval from 175 minus 1.96 times 15 divided by 10 to 175 plus 1.96 times 15 divided by 10. Now, you can put everything into the calculator and calculate. We have the confidence interval to be 175 plus or minus 2.94 centimeters, or the interval between 172.06 centimeters and 177.94 centimeters. Step 4. Conclusion. We conclude the answer as we are 95% confident that the unknown but fixed average height of male adults, mu, lies between 172.06 centimeters and 177.94 centimeters. Being confident in 180 centimeters is a normal requirement for average male models, and we are confident that the average men in the city cannot be models. Now, you can use TI-84 to check your results. First, press Stat, then Tests, and choose 7, Zinterval. Second, choose the tab Stats and enter sigma as 15, x bar as 175, n as 100, and C level equals 0.95. Lastly, move the cursor to calculate and press Enter. You can see that the interval is 172.06 centimeters, 177.94 centimeters, which is the same as ours. Since we are working on confidence intervals, we need to emphasize the following concepts. It is the confidence interval to be random, not the parameter mu. That means if we repeat the study and calculate the 95% CI again, 95% of them will cover the fixed but unknown mu. The graph on the left shows the confidence intervals from 20 samples, assuming the true mean mu is actually 173 centimeters. You can see the confidence intervals are different from sample to sample, but the mean mu is unchanged. On average, there will be 1 out of 20 cis that does not cover the fixed but unknown mu, which is indicated by the red interval in the graph. Lastly, if we desire the margin of error, which is half of the width of the C, to be m, we can determine the sample size as the square of the critical value, z star, times the population standard deviation, sigma, and divided by the specified width, m. Let's make students hate statistics less.